Question 2 gives us this curve here. F of x is equal to x plus 4 over x squared. And we're asked to find the coordinates of the point where the tangent line, so the line that's tangent to the curve, is parallel to the line y plus 2 equals to 0. Hence, find the equation of the tangent and the normal at that point. Okay, so what do we want to know? Firstly, let's look at this equation here. Y plus 2 equals to 0. We can rewrite this in the form y equals to mx plus c, where this is y is equal to 0x minus 2. So we know our gradient equals to 0 at this point. So what we want to do is find out where our gradient is 0. What does that mean? Well, I haven't been given a y here, so instead of dy dx I'm going to use an other notation, f prime of x. But it's the same thing. I'm going to find the derivative of the derivative of this function, which is 1 minus 8 over x cubed. We can actually, if you think about it, this can be written as x plus 4x to the negative 2. So this will differentiate to 1. The negative 2 will come down, multiplied by the 4, give me negative 8, then x to the negative 3. So it's the same thing you see here. And then I'm going to find where that equals to my gradient, which is 0. So if I rearrange this a bit, I actually get x equals to 2. So I'm asked to find the coordinates of the point. So I don't just need the x coordinate, I also need to know what y will equal to. So what is f of 2, which can be my y? F of 2 is going to be, I just substitute 2 back into my original equation. 2 plus 4 over 2 squared. So that's going to be, you can just plug this into your calculator, but it's easy enough without. 2 plus 4 divided by 4 is 1, so this is going to be 3. So therefore, coordinates are 2, 3. So that's the first part. The second part tells us, hence, find the equation of the tangent and the normal at that point. So we need to use this answer here to find our second answer for the tangent and the normal. Okay, so let's do these one by one. Firstly, let's look at the tangent. Well, what do we need to find the tangent? We need two things. Firstly, we're going to need the gradient. But we've got the gradient of the tangent, right? This is the tangent is parallel to this line, and this line has a gradient of 0. So that's easy enough. Then the same thing we need is a point, and this is where our hence comes in, because we know this point passes through 2, 3. Okay, so what have we got? This means we can use our formula y minus y1 is equal to mx minus x1, and just substitute in our values. So y minus 3 is my y1 is equal to 0, x minus 2. This whole side is going to be 0 because of this, so my tangent is y equals to 3. What about my normal? Well, I usually would say my gradient for the normal is equal to negative 1 over the gradient for the tangent. And this is the usual formula that we would use, right? But we can't say that this time. Why? Because the gradient of my tangent is actually 0. So I'd have negative 1 divided by 0. So what am I going to do? Well, I'm actually going to just go back to what does it mean to be a normal. So if these are my axes, as such, and I've got my, let me label them, y and x, right? And I've got my normal shown here, my tangent shown here in green, right? This is my tangent, y equals to 3. What do I know about my normal? Well, the normal is going to be perpendicular to it, right? And what's perpendicular to a horizontal line? Well, it's a vertical line. So now my tangent is going to look like this in a vertical line, and it's going to be at right angles. So I know this is the equation of a vertical line is x equals to something, right? But what does x equal to? Well, we know the point that this has to pass through. This has to pass through the point 2, 3. So I can safely say that this is the x value of my tangent. So in the end, all I have to do to find my normal is write x equals to 2. And we are finished.